So I've got the announcements up. We had homework due on Wednesday. I don't know if there are questions about that. Happy to talk about them if there are. Looks like I'm having internet issues, so I'm going to pause for a second. Okay, I was having internet issues for a second, so I'm going to start over, I think. Let me know if you can't hear me at all. Yeah, does anyone have questions about the homework? That's all I was going to ask. We didn't have class Wednesday because of the wellness day, but we still had homework due. I extended it for a few people. If you're interested in that, let me know. But I'm happy to look at some if you have confusions about it, especially since that's what the quiz is going to be on today, right? So at the end here, we'll do kind of a basic definite, indefinite interval quiz. Do you want to look at any of those homework problems at all?
Do you think you can go over number 3 of the second homework?
Yeah, let's look at that. So this one, definite integrals, is that what you meant by the second one? I think that was the second one. This one?
No, the first one then, sorry.
This one?
Yep.
All right. What are you thinking about this one? So we're approximating this integral, and we're going from 0 to 7, right? So the integral, 1 to 7. At least that's what mine says. Maybe yours is different. But what do you think? So we want n equals 3. How do you start these kind of problems? You with me?
We would take the antiderivative of the function.
So we're approximating, right? We want to do these Riemann sums where we're approximating either using left or right endpoints. So this is where you're doing delta x. You're doing the x values. And then you're doing delta x times the x values. So it's the same as all the other ones around this problem. Maybe you were getting confused by the fact that it was showing an integral and you're trying to do the antiderivative. Does that clarify it a little bit? Jorge?
Yeah, so 7 would be b, a would be 1, and n is 3.
Right. So you get 7 minus 1 over 3, which is 6 over 3. Just 2.
Okay. Thank you.
And then we, it sounds like maybe that's enough. So just to kind of look back at these problems, it's the same as this problem and the same as this problem. It's just not giving you a graph, and the rectangle parts, it's trying to get you to do the whole thing itself. So it's similar to this one too, for example. It's the same process as that one, same process as that one, same process as that one. So 1 through 7, 1 through 8 are all the same. And then once you get into, or 1 through 7, I guess. And then once you get into number 8, that's where you start doing antiderivatives and do the plus c. Other thoughts about the homework at all? And yeah, again, I don't like extending homework all the time. I kind of made that clear, but I'm happy to do it. I'd rather you do the homework than not do it, is always my perspective. So if you need some more time on that, just send me a message. Other homework things or anything before we look at the notes a little bit today? Okay, give me just 1 second to check something. Just popped into my brain I would like to look at real quick. Okay, great. So we were in the middle talking about substitution. Let me switch back over to the notes here. Right, we were trying to undo the chain rule, if you remember. And this is the last topic that's on the test next week. And so it's something we want to know how to do. I'll just remind you, though, before we get started, right, this homework is not due until after the test. So I'm kind of highlighting that again in orange. It's not due till after the test, but it's going to be on the test. And so I'm just trying to give you the opportunity to do enough to prepare yourself for the test, but you don't have to fully complete the assignment. So keep that in mind. But as we're doing these, we're following these 6 steps that are listed here. But the whole goal is to try to like identify something in the problem. Like if we're just kind of looking at the chain rule, remind ourselves what the chain rule looks like. We're trying to look for something in the problem, g of x, that when we take the derivative, we get something else in the problem. That's what's driving the choice of u, right? And so if you remember back to then what the step 1 is, we let u be the thing that's either inside something else or not necessarily inside, but the key thing is when you take the derivative, we get something else in the problem. And so we did that a couple times, and I wanted to remind you of that because this particular one that we're about to look at is a little bit trickier than the ones we've seen so far. But if we look back at the examples we did, looking here, I noticed this was the g part, because when I take the derivative of that, I get something with an x squared in it, and that was also in the problem, right? And so that would be like the g prime. And so that's how we knew that u should be 1 plus x cubed. That's what led to that discovery, right? And so I just want to remind you of that because when we look at this first one, it's tricky and it's not super obvious, at least when I look at it, what should be u in this case. And so let's kind of think it through together. And remember, the thing we're trying to think about is when I take the derivative of what in here, it equals something else in there. Except I can't spell something. There we go. Something else in the integral. That's what we're trying to think of, because that's what we're going to let u be, right? That's what we substitute out. So ideas, and I'm going to try to do this one wrong first, just to be clear. But I'm just curious if everyone has an idea about what they think might be u.
1 plus x squared.
1 plus x squared is a really good choice because it's inside, and everything we've looked at so far is always the g thing's always on the inside, right? But let me just sort of tell you ahead of time that that's not correct. But let's look at why it's not correct. And so maybe the answer is 1 plus x squared question mark. Well, let's take a derivative and see what happens when we do that. Right? When we do the derivative of 1 plus x squared, we get 2x. And there's an x in our answer, right? And so we're accounting for part of it, but we're not accounting for the 1 plus x squared at all when we do that on the bottom. And so this is a good option, and when you take the derivative, it helps a little bit, but it doesn't do everything we want. It doesn't fully account for everything else in the integral. And so what I would mention is, so it accounts for, let me do it another color so it stands out. 2x accounts for the x in there, but it doesn't account for the 1 over 1 plus x squared. And so 1 plus x squared is I would have, when I first look at this without sort of knowing better, I would have thought 1 plus x squared would be a good option too. And I see a couple people, I just missed that in the chat. People are thinking x squared. We're going to have the same kind of issue, right? We're never going to account for the 1 over 1 plus x squared with those options. Does anyone sort of see what is going to account for those things? When I take the derivative of what in there, do I get other stuff in there? It's a tricky one. Other ideas?
ln of x.
Yeah, the ln part. What happens when you take the derivative of ln? Remember that?
1 over x.
If it turns into a fraction, awesome. And so that's how we're going to end up accounting for the things we're looking to account for. So let me just write that down. So 1 plus x squared didn't work, but if I differentiate natural log of 1 plus x squared, right? It's a chain rule. Let me do the details. It would become, you do 1 over what's inside there, which is good. And then you multiply by the derivative of the inside piece, which is also good because we're going to get an x out of that. So that's going to end up being 2x over 1 plus x squared. And that's nice because this is part of the problem. Right? We're going to account for the x plus 1 over x squared. Let me kind of highlight it in here. Right there. Not the 2. We'll have to think about what to do with that 2. But I'm just kind of trying to show why we want u to be the ln part. This is certainly the hardest example we've done, right? And so I wouldn't expect, I'm not going to try to grill you on something like this on a test, but occasionally in the homework or, certainly in applications, you see tricky ones like this. So it's good to kind of think them through. Do people see what I'm saying about how we're accounting for the missing pieces when we do that? Let me see if I can try to leave that there, but snake it up above. Okay. Thoughts about that at all? Questions? Okay, so that's what we're going to let u be. Remind myself how much room we have. We got lots of room. Okay. So, oops. Trying to do this. Oh gosh. There we go. So let's let u be the natural log part. And are there questions about the derivative? I guess I'm kind of taking for granted. Maybe we feel good about the chain rule. Does that chain rule look okay? Happy to clarify that. Okay, so that u is that. And so we just figured out that when we differentiate it, we get this, right? And the 2 is not found up above. That's the kind of thing I'm trying to point out right here, right? What happens with this 2? Well, let's look at what we did previously with that kind of thing, right? In this first example, when we did the differentiation, we noticed, oh, my internet's lagging. Let me let it catch up. Okay. In that first example, when we did the differentiation, we noticed there was no 3. See how it says no 3 in highlighted orange? We were kind of looking up at this example and we were like, oh, well, there's no 3 there. And so instead of leaving the 3 as part of the substitution, we brought the 3 over to the other side and made it 1/3. And then that came with us when we did the substitution, right? We see that in the substitution actually. And so we want to do that same kind of thing here, where we're recognizing back here that, hey, there's no 2 up in the original part. And so I'm going to bring the 2 with me when I make the substitution. I have some issues with my pen right now. Here we go. I guess I can do it in 2 steps. So this is like du equals 2x 1 plus x squared dx, right? Moving the dx over to the other side. And then divide the 2 to bring it with us. So 1/2 du equals x over 1 plus x squared dx. So these are the 2 things we're going to substitute. And you'll see from here on out, it turns into a really easy problem after we make the substitution, of course. And so this is usually the hard part, kind of thinking through what is u, how do I differentiate it, how do I sort of set things up? So what are their thoughts about it so far? Okay, so let's make the substitution. Let me write the original problem again. I guess I'll just copy it down as it's written, so maybe you can make that connection here. I'll just copy it down like normal, right? And what we're seeing here is that the u, Let me also color code this a little bit. The u is going to be the ln, and the 1/2 du is going to end up being the rest of it. Right, so notice what I'm circling in green right now. That is exactly what's right here. Right? Let me do it like this. So that when we make the substitution, it looks like this, right? Becomes integral of u times 1/2 du, which we can think of as pulling the 1/2 out front and then just integrating the u. All right, let me pause there and see how that looks. And I'll particularly emphasize the point that we brought the 2 with us when we did that, right? We brought the 2 over to the other side so that we were able to substitute it in and bring it along. And this is now a super easy problem, right? We're just integrating u. Doesn't get really any easier than that. And so this is the hard part, or we've done the hard part, I mean. Thoughts, clarifications, anything there?
Now we just put in the ln 1 plus x squared.
So we need to integrate it first, right? So first we do the anti-power rule on the 1/2 u part, and then we plug the u back in. What we've been doing so far is setting it up so that we have something to work with, right? And so now we do this, in other words, right? This becomes 1/2 u squared over 2 plus c. Is that okay? Does that make sense?
Mm,
Can I interpret that low grunt as a no, it doesn't make sense?
I guess not. I guess, yeah.
Right? If we, this is the kind of thing I'm going to ask you to do on the quiz, right? If we integrate u du, it's just an anti-power rule. Add 1 to the power divided by the power. That's exactly what this said right here. Can I clarify something about that?
Okay, yeah, that makes sense.
Why did it become u prime?
So I'm just trying to, it's a u to the 1.
Oh, okay.
I'm just trying to make it clear that I had a power of 1.
Gotcha.
Other thoughts? And so now we want to plug the u back in, right? The whole point of taking the u out is so that we can do this integration, so that we can make it easier. We do the easy thing, and then we plug it back in. Right, so this is going to be, I guess I can do it in 2 steps just in case it's confusing, right? The 2's multiply together to give you a 4, and then you can plug the ln back in. What do you think? If this one makes sense, you should feel pretty good about it. And if it doesn't, it's okay, but maybe we could talk about what part.
Is ln x 1 plus x squared u because x is in ln x?
No, we make u ln 1 plus x squared because when we take the derivative of it, we get other stuff that's in the problem. So, right, that's what I was trying to show in a couple places, but the blue thing at the top here, right? I'm trying to show like, hey, when we took the derivative of this thing, look, that's also in the problem. Right, you see what I'm circling right now that I'm going over in red?
Yeah.
X over 1 plus x squared is also in the problem after we take the derivative. That's why we want to make u ln. And what I was trying to show at the top was, in this part, why it's not 1 plus x squared. Because when you take the derivative of 1 plus x squared, you only get 2x. And so it doesn't account for the bottom part of that fraction at all.
Okay.
That's a good question. Other thoughts like that? Those are the kind of clarificational things we want to try to work out here.
Kind of like an essential question, like when we look at these problems, what doesn't work that like makes us have to do this the substitution process?
So yeah, that's a good question. It's always good to remember back at the why are we doing this in the first place? Because if we look at the antiderivative rules, which I keep forgetting are part of the notes, I always close it. In another class I teach, I keep them separate. When we look at these antiderivative rules, none of these, the problem we looked at, for example, just now, doesn't fit into any of these rules.
Okay. All right. Cool. Thank you.
And maybe just to expand on that further, like these are the super basic rules. And if we have something more complicated, we try to break it down and make it look like a more basic rule is sort of one way to think about it.
All righty.
Other thoughts? Keep them coming. Get this one back up here. All right, as a quick review, which is also might also help us with the quiz this afternoon, the difference between definite and indefinite integrals. Right, I'm going to put both of these on there, and that's what the homework is about. So hopefully it's clear to you. But this kind of thing is what I want to remind you of, right? When there's no bounds on an integral, like this first one, right? You have the integral sign, no numbers. That means you're finding the family of antiderivatives. So it just means you do the antiderivative and you put a plus c. And sometimes you need substitution. Sometimes you use the basic rules, but you get a function, right? And that's what we've just been doing over the last couple of days with substitution. What I want to just finish with here is how do we do substitution with a definite integral, right? So a definite integral is when there's bounds all of a sudden, right? There's a b and an a on there now. And that means we're doing the area between the function and the curve. It involves the antiderivative, but then we plug numbers in, right? So it's just like taking the indefinite integral step further is one way to think about it. But how do we do that with substitution when you're like pulling things out and plugging things back in? How does that work, right? That's sort of what I want to think about at the end here. We'll see how far we go. I'll probably end up starting next class with these last couple examples. Okay, and so here's just kind of reminding you a little bit about the two differences, right? Indefinite versus definite integral. You see those two words here, right? Here's indefinite, here's definite. And we can see if we want to do a definite integral, there are two options, right? 1, 2. So I'll kind of talk about them one by one, and then we'll do an example using both of them. Yeah, okay, cool. So one thing we can do is replace the bounds. That's the first option that it talks about right here. Should I make those couple notes? Maybe it's good to just put these notes. I'm just looking at my notes and reminding myself what I wrote. So just as a quick reminder, this is the family of antiderivatives. It's particularly relevant for the quiz this afternoon. And when you do A to B, when you throw an A and B on there, it finds area. Specifically between the function and the x-axis. Please remember that phrasing. It will be important later. Okay, so I'll just kind of rewriting down what I just said in words, right? All right, let's get the actual method. So you have two options. You can either replace the bounds, or we can do a substitution and work on it that way. I think that maybe the easiest thing to do would be the substitution first. So let me work on the one on the right here for a second. So when I say substitute u back in, what I mean is you use the original bounds. So don't change the bounds, use the original one. And so the way that works is, you plug in something for u. We've been calling it g. And then, of course, we make the substitution du equals g prime dx. So I'm just going to write down the process in general so you can think through it, what it looks like without any numbers in there. And then as a reminder, what we've just been doing over the last couple of days that we just did a second ago, it lets us take this really complicated function that looks like this, right? The chain rule thing. And it lets us rewrite it as something really, really easy. And I don't mean to say really, really easy, like, oh, this is so easy, but when you look at the thing on the left compared to the thing on the right, it's obvious that the thing on the right got simpler, right? And so this method that's on the right here, substituting u back in, just says, hey, leave a and b alone. Don't change a and b. Just plug u back in and then do the integration. And so before we plug in a and b, we would do this. We would plug g back in and then go from a to b. Right? So notice what happened between these two steps. It had a u in it to begin with, and then you plugged in the g back in, right? And then when you do that, you just plug the numbers right in like we would normally, right? This is the kind of thing that I'm going to ask you to do on the quiz, for example, this afternoon. Then you just do your f of g of b minus f of g of a. You just plug your points in. And the real thing I'm trying to point out here, that the takeaway, you just use the original bounds. You don't change the bounds at all. But it's after you plug u in. Should we do this example first or look at the other one? Yeah, so maybe let's just go right onto the problem and do this example with that method. And this example we already saw. All right, this example, integral of 1 to 5, 1 plus x cubed to the 4th x squared, was the first example we did, right? And I actually referred to it earlier today. So we already know how to integrate this thing, right? We let u equal 1 plus x cubed. We do this whole thing, blah, blah, blah. And so I'm gonna go through the steps, but I'm not gonna do them in detail. If you want the detail, you can look back at this one, is what I'm trying to say here. But we can still do sort of the general process, right? So remember how this worked. You let u equal 1 plus x cubed. And that let us rewrite the integral like this. Maybe we should just do it together. It lets us take our original integral and rewrite it like this. And so that's the first step on both of these options, is just to do the substitution part. When you actually plug the numbers in is when the either or situation comes up. And so again, if you want the details on that, just look up above at the last answer, or the first example we did. But if we now want to integrate this thing, what option 2 says on the top here is just do the integration, plug u back in, and then just plug the numbers in. And I personally like this method because it's just, let's go ahead and do that. And then you plug u back in, and then we just move forward, right? So you integrate u to the 5 over 5. And then before we do anything, we plug u back in. And then we plug in the numbers. Right, so from here to here, we just plug u back in. And you remember this notation, again, this is the thing that the quiz is on. When you write this notation of 1 to 5 like I did, you write straight line 1, 5. That means I'm about to plug in 5, and then I'm going to subtract, plugging in 1, right? It's like a notation thing. And so we just finished carrying it out. This is going to be I forgot, this should be a 15 though. Sorry about that. 5 times 3 ends up being 15. On the bottom, does everyone see that denominator just changed to 15? And so that's going to end up being 126 to the 5th over 15 minus 2 to the 5th over 15. And let's just leave it like that. You can get some decimal out, and that's fine, but I want to show you that we get the exact same expression when we do it the other way. And so I would refer to this as the basic way, kind of. And this is the way that you don't have to change the bounds. You just keep doing everything we've been doing with substitution, and then you just plug the numbers in. I just want to show you a kind of a different thing in a second here. But let me let everyone catch up and see if there's some questions about that. Does everyone see where that 15 came from? It came from the 3 times 5. Thoughts about that approach? You know, one of the things I'm trying to show you too is, you know, in my opinion, calculus is kind of the gateway to higher math. I mean, there's a couple calculus classes that kind of get you up there. But eventually, once you get high enough in math, you want to be able to make sense of something that looks like what I originally wrote, which I know is there's no numbers in there, right? It's A's and B's and X's and F's and G's. But if you can kind of see how the thing on the top is the same as the thing on the bottom, or maybe more importantly, how the thing on the bottom is an application of the thing on the top, that's what really unlocks your ability to sort of learn higher math, because you can see how a general thing gets applied. Thoughts about what we just did there? Questions at all?
So you didn't, what's it called? Find U prime or something? You just did it?
So I'll just remind you one more time that we did this problem previously. So I'm not going through all the details about integrating it. I'm just showing you how to plug the numbers in after we integrate it. If you want to look at the details about the U and all that stuff, you should look back at this problem.
Okay.
Right. What I did there is I said, I went right from this thing, I showed you what U was, and then I went right to the answer, because I'm not trying to do another example. I'm trying to show you how to take an example we did and then plug in numbers. Other thoughts? Okay, if there aren't thoughts, let's look at the other option. I would call this maybe the more savvy approach or something. I don't know, maybe the more, I don't know. Some people like this one better. I'll just leave it at that. So the other option is you can replace the bounds, and the idea is you don't substitute U back in. So you just work with kind of the really easy version, but when you work with the easy version, it requires you to change the bounds. And so I'm going to do the same kind of general thing here, right? So you let U equal G again, just like we did before. You again make the substitution, du equals G prime dx, right? Nothing there has changed. What changes is the next part. And so our original function, which again is the chain rule, then becomes the simple f prime of u integral, of course, but the bounds are going to change, right? So I'm going to write that in red now. The new bounds are going to be, if I can get my pen working, there we go, g of b and g of a, right? So you take this g function and you plug your bounds into there to get new bounds. And the reason someone would do this is because then you don't have to plug u back in. If it happens to be complicated or cumbersome, maybe that's a nice thing. And instead you just work with your new bounds in the easy function, right? So then instead of, notice how in the last step we had a's and b's here. There's no a's and b's anymore. It's g of a and g of b. Right? That's the difference here. And so if we kind of kept going with this method, we would then work with our f function, and then we would plug in g of a and g of b. But notice how the thing I'm writing down right now is the same as the thing that we had last time. This thing right here ends up being the same as this expression. That's what I'm trying to point out here, and that's what we'll see in the answer. Right? In both cases, you're going to plug b and a into g. The question is, do you do it beforehand and then use the easy function, or do you do it inside the function itself after you've plugged u back in? And so the big kind of takeaway, if you're totally confused, you have no idea what I just said, the thing that you should sort of take away from this thing I just wrote is you should change the b to g of b, and the a, you just plug it into g. And then don't plug u back in. So that's what we'll see in the example down below. Let me just let folks sort of catch up and see if there are questions about the notation. Now seeing that there was a question 5 minutes ago about 1/3. I can try to clarify that. I would encourage you, Sebastian, to look up at where we did that example and try to see where that 1/3 came from. I'll scroll up in a second as soon as folks finish writing. Thoughts about what I've written there, though? Okay, I'm going to explain the 1/3, and I don't want to, how should I say this? I don't want to be rude here, but I've explained kind of where these constants come from every period, of course. I've already done it twice today, and no one's asked a question about it. So I'm happy to like clarify those things, but I explain it to try to clarify it. And if I don't hear an answer, it makes me think that it makes sense. And so it's a little bit, it's just, I feel bad that I did it. I explained it twice and there's still a question about it, right? You should ask me back when I was talking about it. So once again, when we do the u substitution, right, and then we do du dx, I'm noticing that there's not a 3 back in this original function, right? There's no 3 when I look back here. Is there an x squared? Yes. Is there a 3? No. And so I can't substitute the du for 3x squared dx because there's not a 3x squared dx. There's only an x squared dx, right? And so that's why I had to then bring the 3 over to the other side, and then it comes along with us when we make the substitution. And again, it's because the original function did not have a 3 in it sitting out front. I think it's important to contrast that with the second one we did. I did this on purpose when we did it this way. On the second one, we let u be this, and then when we did du dy, it was minus 5y, or sorry, minus 5 dy, right? And then when I look back at the original, I said, oh, good. There is a minus 5 and a dy in the original. I know I just kind of covered it up, right? But you see in this original, there's a 5 and a dy. And so I didn't have to take the 1/5 over to the other side anymore. I could keep it over on the right and then make this substitution, right? The minus 5 dy becomes du. What do you think? I would love to hear someone clarify that. That's still confusing. It's like totally fine. What's not fine is for me to say it 3 times now and then still be confused. You got to say something about it if it's not still clear. Anyone?
it's still kind of a little confusing.
So you do the du dy part, and then you're just looking at the original function. Oops, I think I just did something I didn't want to. Okay. Right. Do you see this thing I'm circling in thick blue now? Minus
Yeah,
5 dy is on the right.
that, like that would, because -5 dy is still like, you still have -5 and -5 in the bottom too. Is that why?
No, it's because it's on the top, right? So here I am rewriting the function, right? This is the same thing that's on the top, right?
Oh, because u is in the bottom.
Yeah, u is the thing that's inside the thing being squared,
Okay.
right? So when we make the substitution, I think this is the thing that's important to look at, this thing right here, right? This thing inside becomes u. This minus 5 dy became du. And
Okay.
if I can color code that, like this is here. This is now here.
And why isn't u like 1/12 minus 5y?
Because I was recognizing that when I take the derivative of just 12 minus 5y, I get something else that's in the problem still.
Okay.
Right? You get the 5 dy, and that was good because that was in the problem.
Okay.
If you let it be 1 over, you're going to have a chain rule thing, and it's going to get more complicated, and it's not going to be something that's in the problem.
Okay.
Those are good thoughts. Thank you. Other things like that? Other clarificational things about the constant?
So you just kind of like take the derivative of all of them separately, and whatever is in the function, that's what you.
You need to think about, yeah, so you think about, like, that's what we were kind of thinking about here, right? We tried this one, didn't work. So then that led us to this one. We tried that one, did work. And so, yeah, it takes a little bit, sometimes maybe a little bit of trial and error on certain problems. I think a lot of the ones in the homework are not super complicated. They're more like this one, right? Like, hey, when I take the derivative of sine, I get cosine. Like there's only so many things in this problem you could possibly be. And so it's not that hard to think through ones, I think, that look like this, or like this one, right? We'll do this one next time. But hey, when I take the derivative of x squared, I get 2x. And so that one should be, right, that's sort of the level that I would hope for that you could do on a test, for example, next week.
What's it called? Can you scroll up for a second? Keep going. Yeah. Keep going, hold on. Yeah. What's it called? No, hold on. It's the ln thing. The one right underneath this one. Yeah. I don't get that one. I get that we're taking sorry. I get that we're taking the derivative of ln, so that would be 1 over x, right? So that's the 1 over 1 plus x squared, because that's what we're doing right here. The next one is multiplication by the derivative of 1 plus x. Where are we getting that one from? So is that because that was the rest of the problem and we're taking the derivative the rest of it?
No, when you do the derivative of ln x, it becomes 1 over x. Yes.
Mhm.
But if we do the derivative of ln with something inside of it, it becomes a chain rule.
Oh.
Right. This is my f prime of g of x. This is my g prime of x.
Okay, that makes a lot more sense now. For the one all the way up top where I was talking about 1/3.
Yep.
The reason, sorry, damn, something's wrong with my throat. I don't know, it's acting up. Since we don't have a 3 in the problem like you were speaking on, we just kept it along with us because like we need this u, we need it. So like we just brought it and we made it 1/3, and then we just eventually used it. Was that it? Was that really it?
That's really it. Yeah. Right. So like it's easy to make. I think it's easier to look at this problem to see why this works.
Because this one has this stuff in the problem, so it fits perfectly.
Right. And so what we did is we just took this thing right out and just replaced it with du, because this literally says du is the same thing as minus 5 dy. That's what equals means. And so we could just take that right out and plug it right in, right? So in the other one, we didn't have that luxury is sort of the idea. We couldn't just replace the 3 because the 3 wasn't in the problem. And so instead it had to move over to the other side, and then it's part of the du side. And so then when we make the substitution here, it comes along with the du. See that?
Yeah, so you divided it, and then that's what made it to 1/3.
Yeah, sorry, that was the problem. Yes, I divided it over to the other side, right.
Okay.
These are good thoughts. I'm glad you're thinking about this carefully. Other things?
So this is what's going to be on the test today at the end of class, or the quiz? Not the test.
No, the easy versions. No. This is substitution. Substitution, we haven't had a homework due on that yet.
Oh, okay.
It's going to be more like the homework from Wednesday.
Oh.
Okay, I would like to finish this last little part though, because we're kind of getting close to where I'd like to start the quiz. And so let me just show you, forget how we got down that sort of tangent. Oh, I noticed a thing in the chat about the 1/3. Anyway, let me just show you that if we change the bounds, I can't believe we got so far away from that. I'm like forgetting about it. So that means you probably forgot about it. The first option is we can change the bounds and then not plug u back in. That's the takeaway. So let's look at that. So let's do it down here, option number 1. And so we plug 5 and 1, because those are the bounds, right, into the u function, which in this case is the 1 plus x cubed. Right, and so 5 would change into 1 plus 5 cubed, which is 126. So that's the g of b part, right? And then the a changes into 1 plus 1 cubed, which is 2. Right, this is my g of b. This is the g of a. And so the nice thing is we don't have to plug u back in, right? We can just work with this really simple version and just use the new bounds. And so we'll have 1/3 integral of u to the 4th du, but now the bounds are going to be 126 and 2. And so some people like this method better because, right, integrating u to the 4th is easy, and then you just plug these numbers right into that easy kind of thing. Some people get confused by it though, which is why they avoid it. You can do whichever one you like. That really doesn't matter. Right? This just becomes 1/3 u to the 5th over 5, and then we plug in the new bounds. And you'll see we get the exact same thing we just happened to get a second ago. Right? So we'll get 126 to the 5th over 15 minus 2 to the 5th over 15. So the thing I'm trying to point out here is you get the same thing. I really don't care which one you do. Totally up to you. I'm not going to force you to do it one way or the other. Just choose one that makes the most sense and practice it in the homework, right? That's the idea, is figure out which one makes the most sense, practice it a little bit, do well on the test. And we'll look at, there's 2 more examples on the next page. So we'll do a couple more at the start of next class as well, of course. But I'm going to stop here and see if there are questions and then shift over to the quiz. So let me know what you think about this.
Can you explain the last one just a little more?
Yeah, so we kind of got off to the side here. So I don't know, maybe it was hard to remember what we did versus the differences, right? And the one on the right, we do the u substitution, and then we plug the u back in. And then we use the original bounds. Okay, so the 3 things I'm trying to highlight are make the substitution, plug the u back in, use the original bounds. On the left, we change the bounds, do the u substitution, don't plug u back in, and then use our new bounds. right? So notice like the three differences there. We change the bounds and use the new bounds, or we don't change the bounds, but we plug u back in. If it's, if it's not crystal clear right now, we're going to look at two examples. We only looked at one example here. So hopefully the next couple will illustrate it. I'm happy to clarify further, but we're going to look at this again on Monday, so we don't have to spend too much time on it right now. Was something I can clarify about what I just said, though?
I guess I'll just wait on Monday.
Okay, I think maybe if you see a couple more, you'll see. And I'll do at least one of them both ways, maybe both of them. I don't know. Other things. Yeah, go for it, Sebastian.
Yeah, there is no school on Monday. I'm pretty sure it's like some holiday.
Yeah, I think that's Patriots Day. Yeah, thank you for that. So there's no. We'll talk about it Wednesday. That's okay.
But what's it called? I think it's just like you picked out your U already, so just plug the 5 and the 1 into the U, and then you good. That's about it.
That sounds right to me. Yeah.
That's pretty simple. I hope she get it.
I think she'll get it. She might need to see one or two more. I don't know if that helped or not, Janetta, but we'll see some more of this.
Okay, well, thanks.
For Friday, just to alleviate everyone's concerns, super basic versions of these things. I probably won't even ask you to do a definite substitution one. I'll probably save that for the final. I'm going to look for you to do sort of basic questions like the one we were looking at here, for example, right? This is sort of the level of difficulty I would hope for on next Friday. All right, anything else before we pivot to the quiz?
Truthfully, could you go over an example of what we about to see on the quiz? I know it might be too late. You might just be like, nah, you should have already known this. But like, I don't know, like
it's definitely too late.
You don't knock, you never get in.
I mean, if you have your homework from Wednesday, you don't really even talk about it. So I'm going to ask you to do stuff like this: integrate x squared plus 6 dx. And then I might put a bound on there and ask you to do the exact same thing. That's the kind of stuff I'm asking you to do this afternoon. If you don't know how to do that, I'm not going to go over it right now. I'm sorry.
Tragic.
I was going to say something else, though. What was it? I was going to look at the schedule just to be sure. I thought I just looked at the schedule. Monday's definitely Patriots Day, but did I not put that in the schedule? No, I did put it in the schedule. Okay, good. Okay, yeah, we're good. We're following the schedule to a T. We're in good shape.
And also, what times would you be free next week?
So I'm actually going to have to move my Wednesday office hours. I'm around lots of times. So I'm generally around during office hours, although I have to move the Wednesday one. Send me some times it seems like your schedule is more restrictive than mine, I would say. So why don't you send me some times when you're available and we can set some stuff up.
Would you be willing to host office hours in our time slot for regular class on Monday? Even if we're not going to have like official school?
Yeah.
Yeah, I can try to do that. I'm actually going to be away. But I can still do that, I think.
Okay.
Also,
Let me consider that. But if not, send me some times you're available and we can, even if we do meet and we want to meet again, send me some times.
Thank you. Yeah.
All right. Can everyone turn the camera on so I could send this quiz around? It's going to be super basic. I don't think it'll take long. And when you're done, I'm hoping you will submit it to Gradescope yourself. Is everyone able to do that? If you're not able to do that, you should drop out of college. No, I'm just kidding. You can email it to me, but you really should be able to figure out how to submit something online. I believe you can do that. Anyway, I'm going to send it through the chat. You're going to write your answers down on a separate piece of paper. You can scan them up with your phone or whatever. Submit it to Gradescope. Questions? I'm going to send it through the chat in just one moment. All right, here it comes. Marcus, Tayshawn, if you guys are there, if you could turn your camera on, that'd be great. Does everyone see that through the chat? It's working for me, yeah. Okay, I'm gonna wait for everyone to open it up, and I want to say one thing about it, two things about it to make sure it's clear. But let me make sure everyone's got it open. Does no one have any issues opening it or anything?
I don't see it in the chat.
I don't either.
Is anyone able to see it in the chat?
Yeah, I saw it.
Who's not able to see it?
Gregor.
Mariana.
I feel like this happened to us before, didn't it? I'll just email it to you too. Is anyone else not able to get it in the chat? We'll go ahead and get started, everyone. As soon as Gregor and Mariana have this, I will say something about it. Come on. All right, Gregor and Mariana coming at you. Gregor, Mariana, you guys got that?
Yeah, I have it up.
Great.
Yep.
So I just want to clarify two things so we're on the same page. What does family of antiderivatives mean? Or maybe I'll just say I don't need to ask.
Definite integral.
So we want to do the indefinite integral, yes. Indefinite integral. And I'm just going to put plus C on there. Hopefully you know what that means. The other thing I want to point out is that in number 2, you can get your part of your answer from number 2 from the previous problem, right? There's a square root, in other words, in the first part, and you can use that information to help you with the second part. Gosh, there's snow falling on my house. Sounds like it's about to fall down. And then the other thing is this function is also the same function in the third part. Okay, in other words, you don't need to like redo the work necessarily on the first parts. I'm just getting you to then plug points in is what I'm trying to do there. Let me know if you have any questions. I'll put my number in the chat in case you want to call me. Hey, for those of you guys who are finishing up and trying to submit, I have forgot that I need to just open it up again. So give me 1 second. Do that. I'm doing it currently. It'll be open in just 1 second. Sorry about that. Okay, it should be open up now for anyone who is trying to submit the quiz. If you're having any issues, give me a call or email me. Okay, now it should be ready. I'm sorry. Hey everyone, given my next class starting at 12:30 and just the general level of difficulty of this quiz, I really need everyone to finish this up in the next 5 minutes or so. I feel like if you're still working on it at that point, you're trying to learn the material, and that's really not the point of this quiz. So please try to finish it up. Thanks.
All right. Thank you.
Have a good one.